Hello all, welcome back. In this video, we are going to learn about analysis of pin-jointed plane frame. So these are the topics that we are going to see one by one. The first we should know what is a frame. It is made up of slender members, pin connected at the ends, and is capable of taking loads at joints. Slender means it's a cylindrical shaped a link which has more length than diameter, which means L by D ratio should be high. And if the two members are joined by a pin connections, which means, as I mentioned in my earlier videos, pin means it's provide free rotation, that a member can rotate or oscillate about this point freely. So also it's capable of taking loads at joints only. Then we majorly categorize the frames into two different types, that is plane or space frame. Plane frame means that all the members in the plane lies in a same plane, which means that either in xy or yz or zx, all the members lie in the same plane. But in case of a space frame means in a certain space all the members are distributed. Like in this roof you can see that this is for example for space frame. And if you see this bridge, it's made up of two plane frames. Plane has another name, we call it as a truss also. Okay, so this bridge is made up of a plane frame, and this roof is an example for a space frame. Then, so it is an important topic. Why? Because means uh, to find the truss or a frame has enough members to withstand the external load. If it has exact number of members to withstand the external load means that is a perfect frame. It has exact numbers. Deficient member frame means it has less member than required. Redundant frame means it has more number than required. So how we are going to find that? There is one formula is there that which we that would be very helpful to find the frame whether it's a perfect, deficient or a redundant. Here M is number of members and J is number of joints. We can use this formula to calculate, to find the perfect, deficient, redundant frames. So you take this example one where the number of joints is 1, 2, 3, 4, 5 and members are 1, 2, 3, 4, 5, 6, 7. 7 members and joints are 5, and if you put that you can get 7, 10, 3 equal to 7. Okay, 7 equal to 7, which means it is a perfect frame. LHS equal to RHS. Then take this example 2. Number of joints 1, 2, 3, 4, 5, 6 and members 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 members are there, and you put this here. 8, 12 minus 3 is equal to 9. So if you look at here that LHS is less than RHS, so this is an example for deficient frame because the members are less. So this is a deficient frame. And if you look at the example 3, you can find 1, 2, 3, 4, 5, 6 joints, and members would be 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10. It has 10. So 12 minus 3 equal to 9 is 10. Here LHS is greater than RHS, so which means that it has some more frames than required. So it is a redundant frame. So by using this formula, we can find the frame whether it's perfect, deficient, or redundant. Then these are the assumptions we take while we are analyzing a frame. In the practical, the members may be joined with a welded or a bolted joint, but while calculation we take it as a hinged joint that we mentioned in the definition itself, that two members are joined by a pin joint, and a load acts as joints only. See, if you take this joint on this joint, load can act here or here, but there is no force acting in between that. No load act in between that. And we also neglecting the self weight, and the members have uniform cross section like this, or it may have a varying cross section like this, but it's centroid located at longitudinal axis. The centroid should act on the longitudinal axis. Centroid where all the mass of this member is acting, that is should act in the longitudinal line. Then there are two types of force that acts on a member. It may be either compression or tension. We usually mention compression like this and tension like this. So, but here that we consider from the point, if a force act like that means in this member, and in this member if we act like this means this member subjected to tension, because you should consider from the point only. So it's going away, so it's a tension. If some force act like this means going inside means towards a point means that's a compression. Actually, it's not a very important thing, because while calculating we could know whether it's a compression or tension. So just to understand the simples and all the things. Then there are different methods for truss or frame analysis. The graphical method, which we don't use now, and we can use the method of joints and method of sections to find the unknown force in a truss or frame. So what is method of joints? It is used only when the list members are there. List members, and also there should be a three force acting point. Three force acting in a point where two are unknown. Then only we can apply the method of joints. It's nothing but where we can apply a Lamy's theorem. If you see this figure means, if you want to find this force means, for an example, there is one force is acting here. You want to find that means you should start from here, because for an example, you say that here 500 Newton is acting, here 500 Newton is acting. So due to similarity, here would be 500 Newton, here would be 500 Newton. So if you consider here, there is one reactant force acting like this, and member force one is like this, and another one might be go in this direction. So here we can apply Lam's theorem. So we have to start from here and we need to find this force. So we have two forces. Then there should be one unknown. So we are moving by a joint by joint. That's what I'm trying to say. So here, then we go here, then we will find here, then we find this method of joints. That's why we are using this method of joints only when less members are acting in a truss and the number of unknown forces should be less. Then only we should use the method of joints. Method of joints. Method of section means that we can use it for a large number of members, and we can find the large means up to three unknown forces, and it could be used for any kind of frame or truss. So we can neglect the method of joint. We simply join the method of section. It's very easy compared to method of joints. So in the next video, I'll explain the procedure and I'll solve one more problem to understand the method of section. Thank you.